All right, so jump back into it. During this part, again, this is going to be a little more technical, science-wise, so please interrupt if you have any questions. So I'm going to open up with talking a little bit about gravity and the Standard Model, as it's known, the Standard Model of particle physics, and why you should care. So it turns out gravity is sort of sitting off on its own. Even on this slide, it looks like it's hanging out with the rest. These three pieces of information, electricity, magnetism, the nuclear weak force, and the nuclear strong force, those comprise what is known as the Standard Model of particle physics. And I see in the little handout, the glossy handout you have, it probably talks about this. Gravity is by far the weakest force of all the forces that we know about. So there's four forces that make up our knowledge of physics: gravity, electricity, magnetism, the nuclear weak force, and the nuclear strong force. What's different about gravity from the rest is gravity only comes with one charge, so to speak. So you know, in electricity and magnetism, you have negatively charged electrons, positively charged protons, and it turns out there's a whole slew of other particles that have different charges. So they come in opposite charges, and the universe as a whole is electrically neutral. And one way you can tell just how powerful electricity and magnetism is as compared to gravity is you played with magnets, right? If you take a magnet and you just hold it near a fridge, it will jump out of your hand and hit the fridge and then hold itself there. Some tiny little amount of magnetism